Hi. The detailed solution for the second example in the cyclic process of Lecture 6 will be explained in this video.
For the second problem, suppose zero point 0.1 mole of a perfect gas having molar heat capacity at constant volume 1.5 R independent of temperature undergoes the reversible cyclic process shown in the right. Calculate the Q, W, delta U, and delta H for each step of the process and for the total cycle. Now, analyzing the PV diagram, we have four steps: A to B, B to C, C to D, and D to A. Now, analyzing step A to B is an isochoric process. So we have a constant volume at 1,000 cubic centimeter, and the pressure varies from 1 to 3 atmosphere. Consecutively, for step B to C, so this is an isobaric process. Pressure is constant at 3 atmosphere and volume changes from 1,000 to 2,000 cubic centimeter. A to B is similar with step C to D. So this is an isochoric process. And D to A, so this is similar with step B to C. So this is an isobaric process. So since we know the pressure varies in each step, and we know that steps are reversible, we can solve by applying equations. dW reversible is equal to negative B dV. dQ at constant volume, so this is equal to CV dt, and dQ at constant pressure is equal to Cp dt. And applying first law of thermodynamics, delta U is equal to Q plus W, we can now solve for delta U. Now, we also need to know the temperature of each state, so from states A to D, by using ideal gas equation. So I will just give one example. So example, at point A, T of A is equal to PA VA over NR. So substituting, PA is equal to 1 atmosphere, VA is equal to 1,000 cubic centimeter. So to convert this to liter, so all over 1,000 divided by 0.1 mole times 0.08205 liter atmosphere per mole Kelvin. So liter, atmosphere, and mole would be cancelled out. So TA, or temperature at A, is equal to 122 Kelvin. Now, substituting the PV values for each state, so I'll just write the answers. For TB, this is equal to 366 Kelvin. TC is equal to 732 Kelvin. And T sub D is equal to 244 Kelvin. Now, solving for step A to B, since this is an isochoric process, we know that work is equal to 0. Now, solving for QAB, so this is equal to N multiplied by CBM times T of B minus T of A. So substituting, so we have 0.1 mole multiplied by 1.5 times R so TB is equivalent to 366 Kelvin minus 122 Kelvin. So mole and Kelvin would be cancelled out. So QAB is equal to 304 joule. Now, applying the first law of thermodynamics, delta U is equal to Q plus W. So, since this is equal to 0, delta U is equal to 304 joules. For step B to C, since this is an isobaric process, work is equal to negative P dV. Now, from B to C, constant pressure is equal to negative 3 atmosphere. Change in volume is equivalent to 2,000 minus 1,000 cubic centimeter. So, with a factor of, to convert it to joule, times 8.314 joule. So, divided by 82.06 cubic centimeter atmosphere. So, calculating, work is equal to negative 304 joules. QB to C is equal to N CPM multiplied by delta T. Now for CPM, this is equal to CVM plus R, and this is equivalent to 2.5 R. So substituting, so we have 0.1 mole multiplied by 2.5 R multiplied by delta T. TC is equal to 732 and TB is equal to 366 Kelvin. So QBC is equal to 761 joules. And then applying first law of thermodynamics, delta U is equal to Q plus W. So we will be getting 457 joules. For steps C to D, so again, this is similar to A to B. So since the process is isochoric, work is equal to 0, Q is equal to NCVM delta T. So we have 0.1 times 1.5 times R times TD minus TC. So Q is equal to negative 608.5 joule. And delta U is same or equal to Q since work is equal to 0. And for the last process, T to A, so again, this is similar to B to C. So since it's an isobaric, work is equal to negative P dV. So substituting, work is equal to 101 joule. Q is equal to N on CPM times delta T. So Q is equal to negative 253.5 joule. And the sum of Q plus work, delta U, is equal to negative 152.5 joule. Now, if we will get delta U total, so delta U total is the summation of internal energy from the four states. So substituting, delta U total is equal to 304 plus 457 minus 608.5 minus 152.5. So we would be getting delta U equal to 0 joule. So this is true that for cyclic process, delta U total is equal to 0 joule. And internal energy, take note that this is also a state function. For Q total, so this is the sum of amount of heat from each step. So this is equal to 304 plus 761 minus 608.5 minus 253.5. So Q total is equal to positive 203 joule. While work total is equal to 0 minus 304 plus 0 plus 304. Plus 101. So work total is equal to negative 203 joule. So keep in mind that work and Q, so they are path functions, so this is not equal to 0. But applying the first law of thermodynamics, delta U is equal to Q plus W. So this is equal to 203 minus 203. So equal with 0 joule.